You eat every day without thinking about it. Not because you're obsessed with food, but because your body quietly demands it. Breakfast turns into energy. Lunch becomes movement. Dinner repairs everything you broke during the day. Now imagine you remove all of that. No calories, no nutrients, no food at all. Just water. And not for a few days, not for a week, but for an entire year. Your body doesn't panic right away. It doesn't collapse on day one. In fact, for a short time, it adapts, which leads to a strange, uncomfortable question. Could your body actually survive on water alone for a whole year, or does it slowly run out of options? Let's walk through it. Day one feels almost normal. Your body still has fuel from your last meals. Glucose, which is just sugar in your blood, is your main energy source. It's easy to use, fast, reliable. By the end of the first 24 hours, that supply runs low, so your body switches strategies. It goes to the liver and taps into glycogen, stored sugar. Think of it like a backup battery, but it's not big. You burn through it in about a day. Day two, something interesting happens. Your body starts breaking down fat. This process is called ketosis, which just means your body is turning fat into small energy molecules called ketones. These can power your brain and muscles when glucose is gone. It's efficient, almost elegant. But there's a catch. Fat isn't the only thing your body starts breaking down. By day 3 or 4, it also begins using protein, which means muscle, not just your biceps, everything. Your body doesn't distinguish between useful gym muscle and essential internal tissue. It just sees fuel. Your metabolism slows down. Your body lowers its energy use to survive longer. You feel cold, sluggish, mentally foggy. But here's the part most people don't expect. You're not actually starving in the way you imagine. Hunger fades. After about 3 to 5 days, your hunger hormones like ghrelin drop. Your body stops asking for food as loudly, not because it's okay, but because it's conserving energy. It's a survival trick. And it works. For a while. By the end of the first week, your body has fully shifted into survival mode. Fat is your main fuel. Muscle loss is ongoing. Water is keeping you hydrated, but it's not giving you anything else. No vitamins, no minerals, no building blocks. And that's where things start getting complicated. Week 2 feels strangely stable. Your body has settled into ketosis. Your brain, which normally runs on glucose, is now using ketones for up to 70% of its energy. You might even feel moments of mental clarity. People sometimes report this as feeling clean or focused. But under the surface, your body is negotiating trade-offs. Your gut slows down dramatically. There's no food to process, so your digestive system basically goes into standby mode. The trillions of bacteria living in your gut, your microbiome, begin to shrink. They depend on food fibers. Without them, entire populations die off. And that matters more than you'd think. Because those bacteria help produce certain vitamins. They help regulate your immune system. They even influence your mood. So while you feel lighter, your internal support systems are quietly degrading. By week 3, electrolyte balance becomes a real issue. Electrolytes like sodium, potassium, and magnesium are tiny charged minerals that keep your nerves firing and your heart beating properly. Water alone doesn't replace them. Your body starts losing them through urine. And here's the danger. Even small imbalances can disrupt your heart rhythm. Not dramatically at first, just subtle, irregular beats, a skipped pulse here and there. Easy to ignore, until it isn't. By week 4 to 6, weight loss is dramatic. Not just fat, a significant portion is muscle. Your body is still choosing survival, but is choosing carefully what to sacrifice. It reduces reproductive hormones. Fertility drops. For many people, it shuts down completely. Because from your body's perspective, reproduction is optional. Survival isn't. And here's the twist that surprises even researchers. Your body becomes incredibly efficient at staying alive with very little. Your resting heart rate drops, your blood pressure lowers, your body temperature decreases slightly. It's like your system switches into extreme low power mode, like a phone at 1% battery. But that efficiency comes at a cost, and that cost is starting to accumulate. By the second month, your body has established a new normal. You're still alive, functioning in a limited way. Your body is now deeply adapted to using fat and ketones. Muscle loss continues, but at a slower pace, because your body is trying to protect what's left. Here's something fascinating. Your body activates autophagy, which just means it starts recycling old, damaged cells for parts. It breaks down worn-out proteins and repurposes them. It's like cleaning out a cluttered garage and using the scraps to survive. This process is actually beneficial in small doses. It's linked to longevity and cellular repair. But here, it's not optional. It's survival. And here's the part nobody expects. Your body actually improves some systems. Inflammation, which is your body's response to stress and damage, can decrease. Blood sugar becomes extremely stable. Certain metabolic markers look better. On paper, parts of your body appear healthier. But zoom out. You're not building anything new. You're just getting very good at using less. By the third month to 6, the tension becomes clear. Your fat stores are shrinking significantly now. And fat isn't just energy. It also stores fat-soluble vitamins like A, D, E, and K. As those reserves deplete, deficiencies start to appear. Vitamin deficiencies don't always hit dramatically. They creep in. Your vision may worsen in low light. Your immune system weakens. Wounds heal slower. Meanwhile, muscle loss continues, including the most important muscle you have, your heart. It gets smaller, weaker, still beating, still adapting, but not as strong as before. There have been documented cases of prolonged fasting, not a full year, but several months, where individuals survived under medical supervision. One famous case lasted 382 days with vitamin supplementation. But here's the key difference. They weren't relying on water alone. They were supported. Your body, without that support, is running out of essential materials. And yet, it keeps going. That's the strange part. By month 6, you might still be alive, but you're operating on borrowed time. Your body has used fat. It has reduced muscle. It has slowed every system it can. It has recycled damaged parts. Now it's facing a harder truth. There's nothing left to cut without consequences. From months 6 to 12, survival becomes less about adaptation and more about limitation. Electrolyte imbalances become more dangerous. Without intake, maintaining proper levels becomes nearly impossible long-term. Your nervous system depends on those signals. Your heart does too. Your immune system is now significantly compromised. Infections that your body would normally handle easily can become serious threats. And here's a reframe that changes how you see everything that came before. Water keeps you alive, but it doesn't keep you functioning. There's a difference. Your body can stretch survival much longer than most people think. Weeks, even months under the right conditions. But a full year? Without nutrients, without vitamins, without electrolytes, the systems that quietly kept you alive at the start are now the same ones struggling to hold on. Eventually, something gives. Not all at once, but enough. So can your body survive on water alone for a year? No, not because it fails immediately, but because survival isn't just about having fuel. It's about having the right pieces to keep everything working together. Your body isn't just an engine that burns calories. It's a system that constantly rebuilds itself. Every cell, every enzyme, every signal. And water alone can't supply that. What this really shows you is something deeper. Your body is incredibly adaptable, far more than you probably realized. It can stretch resources, slow itself down, and reorganize priorities in ways that feel almost intelligent. But it's not invincible. It's strategic. It survives by making trade-offs. And eventually, those trade-offs run out. So the next time you eat something simple, a piece of bread, a handful of fruit, It's easy to see it as routine, but your body sees it differently. It sees raw materials, a chance to repair, a way to keep everything running without having to sacrifice itself. And that's the part most people never think about until they have to.